This enemy attacks and chases the player perfectly, but if you code it using if-else statement, you end up with this mess, which is already 100 lines long for only 3 actions, and will continue to become an even bigger mess as we go on and on. So today we are scrapping this mess and building a finite state machine. That is the architecture used by professional studios to make complex AI. So let us first start with the logic of what a FSM is and then write the code. So what exactly is a finite state machine? Simply put, it is just a fancy way of saying my enemy can only do one thing at a time. Think of your enemy to be made up of bunch of switches. In the previous messy code, all of these switches wanted to be on at the same time. We were checking for attack state, chase state, idle state, etc. all in one frame. But in a state machine, this rule is absolute. That is, if our idle state is on, everything else must be off. This changes how we think. If we are in our idle state, we don't care about whether we are attacking or running, etc. We only care about one question: are we close to the player? If the answer is yes, we turn off our idle state and go to our chase state. And now the chase state has the full control. And the beauty of this thing is that we did not need to check that whether we were attacking or we were stunned, etc. Because if we were, we would not have been in this chase state in the first place. And this is the best part. If we want to add in a new behavior, let's say patrol, we don't need to rewrite the whole code. We just add in a new patrol state and plug it in. No spaghetti, no broken logic. So how do we build this in Godot? Well, Godot is based on nodes. So essentially all of these states are just a bunch of nodes, and this whole system is called a state machine. Now let us open the editor and write the code. First, we need a blueprint. Create a new class called state. Every state needs access to the physical enemy and the state machine. Instead of using the fragile get parent, we will add references to them here and inject them later on. Finally, we define our virtual functions: enter, exit, update, and physics update. The names are pretty self-explanatory. The enter function will run when we enter into a state. The exit function will run when we exit out of a state. These two functions are useful for initially setting up and destroying our... you will see why when we write the enemy chase code. And finally, our update and physics update will run in place of the physics process and process function in Godot. Okay, now let us write the brain, that is the state machine. The script holds a variable for the current state, and in our process and physics process function, we just write this current state to do its job. Next, in our ready function, we assign the references to our enemy and state machine to all of our children, the children of the state machine being the state themselves. And finally, the most important function, the transition function. This handles the swap. We exit the old state, update the variable, and enter the new state. Now for the fun part, you will see how small the code becomes. Make an enemy idle state. Add in a reference to our player, and in our physics update function, we just check whether the player is close to us or not. And if yes, we transition to our chase state. No boolean, no if else, no spaghetti, nothing. Also notice how I am using the enter function to initialize the idle state. Anyway, our chase state is similarly very simple. If we are far from the player, go to our idle state. And here we use the exit function to set our velocity to 0, as we will not be moving when we are in the idle state. This will be use both the enter and exit functions to kind of initialize and destroy our states. Now to hook it all up with our enemy, go to our enemy node, add in this state machine node there, and as its children add 2 empty nodes and attach the idle and chase script to them. Rename these nodes to idle and chase and assign the idle state as an initial state in the state machine's inspector. And we are done. Let us run it. This is clean, and we can now actually modify this code in lots and lots of ways. For example, our movement is still pretty dumb. We just move in a straight line. So if this video gets enough views and likes, I will make a sequel wherein I will inject strategy patterns into the state machine to give our enemy complex AI like flanking and ambushing without rewriting any single code. So yeah, if you want that video to come out, don't forget to like and subscribe and comment to boost the algorithm. And I will catch you guys the next time. Okay, bye.